Okay, guys. Today we're going to cover some JavaScript, some actual programming. I'm going to basically tell you all the fundamentals you need for programming on this video. We're going to go over them kind of quickly, but if you understand these basics or these fundamentals, you should be able to go over to pretty much any programming language and be able to program in it. And I know that sounds like crazy, like, yeah, okay, no, I won't, but you're going to find that once you learn these fundamentals, these are going to be really the blocks or the pieces you're going to use every day. And it doesn't matter what technology you're working in, these pieces are going to stay pretty much the same, at least in terms of programming. The syntax will change, what different technologies call it, or the nicknames, the terminology, stuff like that will change. But once you understand that it's all the same underneath, it's all these core concepts, these same concepts, then you're going to be like, okay, well, now I'm doing JavaScript and I know about, conditional statements. So what I need right now is a conditional statement, but I'm working in Python. So you just go look up conditional statements in Python. And then as soon as you learn their syntax, you already know how to use conditional statements. So you're just going to use them. Kind of like, if you're going to build a house is built with the same materials pretty much, regardless if it's a small house, big house. You're still going to use fundamentally the same materials. You're going to use a lot of the same concepts. You're going to build a wall. Even if there's 20 walls, it's still a wall. So as long as you know how to build walls, even if it's a fancy wall or a ghetto wall, or it doesn't matter, you know how to build walls. A wall is a wall, so you can go build this house. Programming's kind of the same way. You just need to understand the building blocks, the pieces that go into basically completing a task, which is, it's similar to math. You will use some math, but really it's actually more similar to logic. So programming is going to be more like solving a logic puzzle really than a math puzzle. You can use math to do it, and obviously you use logic in math sometimes, but programming is going to be more about logical breakdown. It's going to be, okay, how can I logically accomplish this? How can I logically get this done? How can I logically deliver on this feature? And these basic building blocks I'm about to show you are what we are going to use to do that. So I'm already in the no, I am not in the project directory. I apologize. That was a work one. Ignore that. Copy absolute path. Change directory. There we go. All right. All right. So, bam. We're going to start it up. And we should be good to go on localhost 3000 now. Okay, so here's basically what we left off with last time, right? All right, so we can take this away. This isn't going to matter. So go ahead and go to page. In here is not going to matter too much. We can leave this alone. In here, though, this is the script tag here, is the code functionality that is essentially attached to this view component. You see how we're in pages? I know that this terminology is going to be a little bit misleading. There's components, there's pages. Later I'm going to show you something called layouts, which are basically just pages at a higher level. Underneath the hood, the whole concept of pages, components, layouts, that's all a Nux thing. Nux is, remember, a framework or library we're using that sits on top of Vue that makes Vue, working with Vue, a little bit easier. And Vue, of course, is just a library for JavaScript that makes working with JavaScript a little bit easier. So Vue makes JavaScript easier, Nux makes Vue easier. So now we got super simple JavaScript, basically. At any rate, any files that you see that end in like this .vue, they're essentially underneath the hood a Vue instance or a Vue component, and every Vue component consists of its HTML, which is everything in between these template tags, so all of this, right? It's JavaScript, it's code, it's data, which is all going to be defined in between these braces, this export default here, and its style tag. Okay, we went over this before, and this is all CSS within here. And you typically want this to be called what's called scoped. Putting the word scoped means that the style tag only applies to this HTML. Leaving this off means that it'll apply to anything loaded on the page while this component is loaded. So you typically want to have scope. I didn't go over that last time. I didn't want to overwhelm you with the CSS, but just so you know. All right. Now, what I'm going to do is every view component, view instance, has a particular set of properties, and they also have what's called lifecycle hooks. Lifecycle hooks are things that trigger during certain stages of this component or instance life. One such hook is called the mounted hook, and basically we put mounted. We create a function out of it. I'll explain functions in a second, so don't worry if you don't understand that just yet. That's part of today's lesson. But for now, I just got to get us somewhere where we can start writing some code. So mounted is a hook. So mounted means when the component has mounted onto your page and basically finished loading. So when the component is loaded and ready to go, its mounted hook fires. So any code we put inside the mounted hook is going to fire when this component is done loading. We can also do something like before mount or before create, which is this gets fired right before it's mounted. So the component has loaded but has not finished setting itself up. It's not finished mounting yet. It's not ready to go yet, but it is loaded on the page. This will fire right before it gets ready to go. When it's done doing it's ready to go, when it's completely ready to go, this fires before the component's even created. You can put functionality. It's not that important to understand all of these. For the most part, you're going to use two: mounted, which is when it's done loading entirely, and before destroy, which is right before it gets removed from the page. So these are pretty much the two that you're going to use more often than not. There's also a property called methods, which is just a way to store functions on here. Like you could put my first function, and that's all you're going to store. Sorry, that's really loud. That's all you're going to store in methods. It's just a way to store functions for this particular component or instance. And the reason we store them here and not globally here, which you could technically do, you could put my second function and it's within the script, so I mean it is technically valid, even though this is complaining for some odd reason. But it's not going to be accessed by the actual view component. So if I were to put a button here, for example, and I were to put an @click, if I want to fire a function, that function has to be defined within the methods. So now I've just added a button, and I can show you this here. And within the button we'll put click me. It's going to fire my first function, which is this code here. And let's just put a simple alert. Yes, you clicked a button. Alright? Really, really simple. So basically, this button, this is just basic HTML. The @click is a view property that is basically assigning the click functionality of this button to call this function. This function is accessible here because it's defined here. If I don't have this here, you'll see this turns white. It doesn't recognize the function anymore. It has no access to it because it's not defined there. But as long as it's within this method section, I can call it from within my HTML. So then if I go to the page and I click here, boom, that functionality fires. We have that alert, okay? Now, we're going to go with mounted for now. Mounted is just basically on load. This will be the easier way to fire code. You don't have to, the user doesn't have to initiate it. It's just going to happen as soon as the component gets done loading, or the page, or the layout, whatever this is attached to. And I'll show you that here. Sorry, my computer's going a little bit slow. I have Unreal Engine 5 installing right now. Alright, so if we do that instead, and we refresh the page, boom, it's going to happen automatically because we're mounted, right? Alright, so that's just some specifics about how to use Vue and our frameworks and the way we have stuff set up. That's not necessarily specific to JavaScript. That's just kind of how we're going to get code to fire and execute. So that should give you some comfortability, some familiarity. You could do quite a bit with that already, and I'll show you that here in a minute. But let's now talk about those fundamentals I was speaking of. In JavaScript, you're going to have, or in all programming, not just JavaScript, sorry, all programming, all software engineering really, all programming anyway, you're going to have variables, okay? You're going to have condition statements, okay? Statements, yeah, there we go. And you're going to have functions, all right? And let me think, also we should go over loops. And you're going to have loops, okay? These are your basic fundamentals you're going to find in every single programming language. No matter what programming language it is, you're going to find these. Sometimes they're going to go by different names. Even some of the specifics we're about to go over will have different names, and I'll go over those in a second. But these are your fundamentals in everything. Using these, you can basically create any kind of logic. So, for example, or not for example, we'll do some examples in a minute, but let's go over each one individually. So variables then are just like it is in algebra. If you're familiar with algebra, I know some of you are, some of you might just be going through that right now. You have basically like x equals 3, right? Or x equals, or y equals 5, right? That's a variable. That's going to apply here. Now, again, how you declare a variable, like how you actually set a variable up, is going to be a little bit different in every language. In JavaScript, there's 2 ways that you would basically do it. You can do let, and you can do my first var equals 1, okay? Or you could do const, my second var equals 2, all right? You can name them however you want. It is typically a good idea to name them relative to their either usage or their data type. And we're going to talk data types here in a second because it's very important for variables. In this case, my first var and my second var is usage. If this were something like player count, then I might do let player count equals 0. If this number was intended to represent a count of players. And what this does is it does 2 things. It not only makes your code more readable in the sense that it tells someone what this is for. If you're reading my code, you're going to be like, oh, okay, well, this variable, he's going to use it to keep track of his players. Very obvious, right? Well, it also indicates the data type. In this case, oh, it's a count, so it's likely to be a number, an integer. And that's very important because it's going to come into play here in a minute. So what's the difference between let and const, okay? This is more of a best practice kind of deal. You technically could just use let for everything. And if you're familiar with older JavaScript, you might even have seen var, my third var equals 3. I almost don't even want to teach this to you. Don't use it. It's obsolete at this point. It will always be let or const, okay? Let or const. And the difference is that a variable defined with let, like my first var, it can have its value changed later. So I could then here go my first var equals 3. So at this point in the code, all the way up to here, this variable is equal to 1. But as of this line and down, or moving forward, depending on how the flow goes, because it's not always linear, sometimes there's callbacks and a chain and whatnot. But at any rate, from this point forward in the code, this value is now going to be 3, because I've overwritten it. Well, if I try to do that with const, I'm going to get an error. So if I were to do my second var equals 4, you're going to see that my IDE is telling me this isn't going to work. Now, if your IDE is not as advanced as mine, it may not tell you this is an error, but if we were to save it and we were to look at the page, you're going to see we're going to get an error anyway. And it's my second var is read only. So what const does is it basically states that the overall value of this variable cannot be changed. Once it's defined, it cannot be changed. It's going to be constant. So const is literally short for constant, okay? Now, there is a bit of a hack / exception to this. It's not really an exception, but it's just kind of a weird example, and that's going to be we'll go over data types again here in about 2 seconds, but let's say my first object equals, and I put first name Jeff, okay? So this is an object. I'll go over what an object is in a second, but for all intents and purposes, it's an object, and it has the data property first name with the value of Jeff, and I have defined it as a constant. Now, because it is an object, I could not do this. I can't do this, okay? Because it's a constant. It won't let me. If I were to do let, I very well could do that. JavaScript is not a strictly typed language, by the way. Just because I created this as an object, even because I named it as an object, it doesn't matter. I can later change it to a number. Typically, you want to try not to do that. If I call this first object, it should basically stay that purpose moving forward. If I need a number, I should just create a different variable and use that number however I need to use it. You shouldn't mix up like that. Mixing up stuff like that makes people think TypeScript should exist, and TypeScript is a plague to mankind, so don't do it. Do me the solid, future generations fight TypeScript. At any rate, if this is a const, I still cannot change the actual object itself. Like, I can't take this object and change it. Sorry, that's Unreal Engine again. I can't do that, but I can change properties of the object. So if I were to go first object, and this is called object notation. This is something that JavaScript uses. Some languages do it this way, others don't, but there's always some way to navigate the properties of an object in a programming language. JavaScript will do it like dot first name equals John. All right, and the result of this is going to be basically this. If I were to do console.log, or even alert, let's alert it. If I were to do alert first object dot first name, okay, you see it's going to say Jeff. And then if I do it after this point in time, it's now going to be John. So let's go back. Let's refresh. Jeff, John. All right. So with const, and if it's an object or an array, because those are basically things that hold a lot of other things inside of them, you can change the inner contents of those things, but you still can't change the outer level thing itself. So that's just the exception, all right? Don't worry about understanding objects and all that too much. We're going to cover that in a second, but I just want you to understand the difference between let and const. When you define something as const, it's going to be kind of a constant value. If it's linear, if it's just got one level of data to it, like it's a number or a string or something, you're not going to be able to change it at all. If it's something that holds other things inside of it, you will be able to change the contents, but you still can't change the overall level of thing. Now, as a rule of thumb, you should typically always make something const unless you know for sure that its value needs to change later. If it is always going to be, like, if it's an object, for example, I will always make it const, because I'm never going to overwrite that object to be not an object. I may change the inner properties, but I can do that by making it const anyway. And I always want that object to be an object, so I'm just going to make it a const first object. And now I am confident that this variable will always be an object. Its innards may change, but it itself will always be an object. And not a new object. It'll keep that reference. Don't worry about internal references. That's some complex crap. JavaScript is pretty smart about it. It'll do a lot of it under the hood. We can worry about referencing when you run into those problems, and you'll start to learn it as you have to progress through the hell to fix it. Okay, so let's talk data types. And so all variables, which is basically just, data assigned to some kind of little nickname short word that you give it, is going to have a data type, okay? And you can always tell what a data type is by doing type of, and then your variable. So if I still had my object constant, my first object equals da. This is just an, oh, come on. This is just an empty object, right? Type of my first object. All right. And then if I go to the page and I refresh, it'll say object. Okay. If I were to put it to this, a number, you'll see it'll say number. Now, one great thing I love about JavaScript, and another reason why I hate TypeScript, it is the fucking devil, I swear to God, is JavaScript doesn't care what the number is. 0.1, that's still a number. Haha. 9 billion, million, trillion, quadruple, zillion, huge ass fucking number that is like an insanely large number is still a number. Now, if you were to go to languages like C++, Java, anything that is considered a strictly typed language, or TypeScript, which they're trying to put into JavaScript now, you have to break your numbers down into further categorizations of integer, which is basically a whole number. It can be any positive or negative number, but it has to be a whole number. Then you have what's called float types, float values, which are anything with a decimal. Then you have what's called doubles, and doubles are used for both integers and floats, so 1, or 0.3, but when it's a super large number. So if you had like that would have to be a double in a strictly typed language. Well, in JavaScript, it doesn't care. It's all a number, okay? If it's a number and there's no quotation marks wrapped around it like this, it's a number. Because this is a string. Even though the string is a string of a number, this is still a string. But this, a number. Doesn't matter if it's this, that large number I showed you, it's all a number, okay? JavaScript is beautiful. Keep it beautiful, please. It's a number. As I just mentioned, this is a string. It's just treated like text. True and false are what's called booleans, or just bools for short. Basically, they are literally exactly true or false. That's the only value they have, yes or no, true or false. You can do the same thing with 1 and 0. Technically, 1 still evaluates to true and 0 still evaluates to true, but you should try not to do that. If your logic is specifically looking for a true or false, a yes or no, use a boolean. Do true, do false. Don't do 1 and 0. It's just sloppy. All right, so we've covered strings, we've covered numbers, we've covered booleans. There is date types. You can do new date, and that'll create a JavaScript date. So then if you do type of and we look, it actually treats it as an object internally, but if you were to spit out the value of it, you're going to get a date object. So it's still an object internally, I guess, for all intents and purposes, but it's a date object. So I guess that's still just an object. You have objects, which we discussed. Objects, you use the curly braces, and then you can just put a bunch of data properties. It's just like a key pair. The properties you put are just normal JavaScript variables. And the reason you would do it this way is, like, let's say that you are making an application about a pet. You want to feed the pet, track its hunger, track its digestion for poop simulation or whatever, track its happiness. You're going to be keeping a lot of data about this particular pet, right? You could do something like let health equals 100 and let hunger equals 50. Okay, that's one method. But a cleaner way to do that would be to do my new pet equals an object, and then you can do health 100. All right, and then you can do hunger 50, and then you can do something like, if you really want to get super advanced with it, you can do something like stomach contents, and you can make it an array. An array is another data type that we are going to talk about now. We'll talk about in a minute. Okay, let me finish objects, I guess. And that's an object. So then, if you wanted to change some details about the pet, or if you wanted to get some details about the pet, you could do new pet.health. Okay, and you'll see that when we refresh the page, we get the health of the pet. If we wanted to change the health of the pet, we could do my new pet dot health minus equals 5. All right. You could also just do equals 5, which will set it to the flat value of 5. But let's say that the pet stepped on a thorn and you wanted to take 5 points of damage instead. You just want to take 5 away. You could just do minus equals 5 and you get this. Another strategy, you could do this. You could do my new pet dot health minus 5. So this is fine. But a shortcut to this would be to just do this. All right, and it's the same thing with plus. So that's a little trick you could use. And if you just want to set it to a flat value, you could do this. If you want to set it to some random weird logic, doesn't matter, you could do that. If you want to set it to 5 times my new pet dot, if you want to set it to its hunger level, okay? 5 times its hunger level for whatever reason. You could do that. And, you know, this is basic math, so subtraction, addition, multiplication, division, okay? All right, now, that's objects. Very, very simple. An array is basically just like a list. And, you know, in, what was I working in? It was Java. Java calls them lists, literally calls them lists. C# calls them dictionaries. It's really weird, but they're arrays. Most programming languages will call them arrays. And it's literally just the square brackets, and everything in it is just its item. So if I were to put 1, 2, 3, 10, okay? This is just a list of objects, and they literally are indexed based on their count. So if I wanted to target this value, I would target it by index. One weird thing about arrays, and in some languages, very few, indexes start at 1 and not 0, but that is considered the abnormality. Most developers know it at 0, and JavaScript uses 0. So if I were to do stomach contents 0, or nope, sorry, because I have it on pet. I have it on an object, so I would have to do it like this. My new pet stomach contents 0. All right, that's going to spit out 1, because that is the value that I have stored in the 0 slot. If I were to change this to apple, let's say that apple is at the firstmost spot in the stomach contents, then it's going to spit out apple. All right, the 0 here is just a reference to what slot within this list that we're picking. So if it's slot 0, it's the first one. Slot 1 is going to be technically the second slot. I know that's a little bit unintuitive, but it gets easier when you get used to it. So if I had an orange here, and I wanted to get the orange, I go to 1. If this were a pineapple, and I wanted it, I couldn't go 2, because 2 is technically the third slot, right? I'm going to get the 3. I would have to go 3, which is technically the fourth slot. Again, I know that is unintuitive. It is just the way programming languages are, but trust me, when it's set to 1, it's even more confusing for some reason, because it collides with other ideas later on. At any rate, if you want the first slot, when you're accessing indexes of an array, just keep in your mind they start at 0, not at 1. 0 is the first slot, 1 is the second slot, 2 is the third slot, 3, index 3 is going to give me the fourth slot. This is going to give me pineapple. Even though pineapple is the fourth thing in that array, it is in slot 3 because slot 0 is a thing. Okay? This is an array. Arrays can have just like object properties, just like the property here, it can be an object, it can be a boolean, it can be a number, it can be anything. Arrays are the same thing. Arrays can hold any data type. I could have a boolean here, I could have boolean, I know it's probably the proper pronunciation, I just call it bools. I can have a bool here, I can have a string here, I can have a number here, I can have an object. Typically, you probably would not be storing a whole bunch of different things of different data types in here. Typically, stomach contents would probably all be object references to some type of food object, like an orange and a decay value, and it would have its own kind of data attached to it. or it would just maybe be strings if you're kind of being simple with it. You typically would not have an array stored with like this many different data types. They'd almost always be the same data type in an array, and as a terms of best practice, you should try to make sure that it is always that way. You should use your variables for very specific purposes and try not to like, don't just make, don't just do like, let my program's data and then just throw a whole bunch of crap in here. Don't do that. Keep it very specific. All right. That is basically variables. That's all your different variable types in a nutshell. A couple of different things you can do, and I guess this will come into condition statements, so I'll show you that in a second. So let's just take this out, and I'm just going to throw it down here for right now, because we're going to come back. We might use some of this later. We'll just kill it. It's fine. All right. So that was variables. Okay. So variables are basically just data attached to some kind of structure with a nickname. Whether it be in an object, in an array, or it's just a flat data value itself attached to a nickname. It's just used to keep track of data for you. And that way you can, when you're doing logical things, you need to keep track of data to solve the logical puzzle, right? If you're solving a Rubik's Cube, you need to keep track of the colors on the squares. All that is data that has to exist. So that's variables. Okay? Condition statements are used to evaluate things. Like, let's say that you have stepped on, or we'll say stepping on landmine equals false. Okay, so let's say we're building a video game and we have a character and we have an object, and this object character has this variable on it, and it's stepping on a landmine. And anytime he steps on a landmine in the code, we set this to true. Okay. Well, now if we want to basically check if that's true and do something, we use a conditional statement. So we would say if stepping on landmine equals true, then we say, boom, you dead. All right. Else, nah, you good. Okay. I like to do little silly things when I'm debugging. It just kind of makes the activity more interesting. Feel free to do lots of silly stuff. If you ever look under the hood of some of my code, you see some pretty ridiculous comments in console logs sometimes. I think it keeps it fun. So basically, it's just a condition statement. It's almost speaks for itself. If this variable equals, which means equals exactly this value, then this will happen. Otherwise, this will happen. Okay. Now you can do something like this. There's also what's called an else if. So let's say we had health, right? And you could do something like if health equals, or we could even say is greater than or equal to 100. Let's do 90. All right. Alert. You are good on health. Okay. Now, let's say that we want another range. Let's say that health is greater than or equal to 50, but health is less than 90. We don't even have to say that. We could just do it this way. All right. Basically, because of the way we set this up, logic will happen when you have condition statements attached to each other like this. They will only fire one of them. So I'll demonstrate that. I'll explain a little bit better here. So we'll say low, we'll say okay. All right. So basically what will happen here is if health is greater than or equal to 90, so if it's 90 or above, this logic is going to happen. If this is not true, it's then going to try to evaluate the next one. If that's not true, then the next one, and so on and so forth. You can have as many of these as you want. All right. Then, in a block, though, you should only have one if. You can have as many of these as you want, and then you should only have one of this. This is kind of like the default. This is like saying, Nothing else above here has been true, so we're just going to resort to this. In this case, if they're 90 or above, this is going to happen. If this did not happen, but they are 50 or above, this is going to happen. So that's, by putting it this way, it's the same thing as saying, and health is less than 90, right? Because we don't want both to fire, we only want one to fire. If we were to do this, if, and then else, this if is its own chain. This if is now part of this chain. So either this or this will happen, but because this is not an else if, this is just a normal if, both of these ifs can actually happen now. So you don't want that. And if you did code it like this, you would have to add this little additional check here, and this means and. This is true, and this is true. That's how you do additional statements. If I wanted another statement, I could put and farts equal, smelly. And I would have to have a fart variable defined. But ands basically just add an additional condition logic in there saying this also has to be true. There's also what's called or, which looks like this. And that just means this or this has to be true. Okay? One or the other. If one or the other are true, then this logic will fire. Okay? You could get really complex with this. You could do things like farts equal smelly, and then you could do something like this. You could use brackets, so it's just like PEMDAS in algebra. You could put them, sorry, not brackets, parentheses. You can put them in parentheses, and then basically what it's saying is this has to be true, and this parenthesis statement has to come out as true. But for this to come out as true, the internal two statements now have to evaluate. So basically this says farts have to be smelly, and health either has to be greater than or equal to 50, or health has to be less than 90, one or the other. You could also put and in here. So you can get really complex with these conditional statements. There's really no limit to how down in the woods how granular you can get with this. But in a nutshell, this is the basics of condition statements. And again, if you use the else if appropriately, you don't necessarily need to put that extra bit of logic there, because since it's in a chain, only one of these are actually going to execute. Only one of these can execute, and it'll go down the line. If the first part of the chain isn't true, it'll try the next one, the next one, the next one. Once it executes one, it skips everything else. If this else if goes off, this else never happens. If I were to put another else if here that said greater than or equal to 20, you could put low, and then you can put something like super low. Well, if this one goes off, this will never go off. If this one goes off, this will never go off. That is condition statements. Okay? That's it. That's basically everything on condition statements. Now, there is a little bit of a trick. You can use inline if you want. There are situations where you would do this, and it's just kind of easier. Like if you want to set a variable to something and you want to set that variable conditionally, instead of doing something like, if stepping on landmine equals true, then health minus 10, you could do something like what's called a ternary expression, which is stepping on landmine, and you would just do a question mark. Everything before the question mark, everything between the equals and the question mark is considered a conditional statement. So it has the same logic. If stepping on landmine and farts equal smelly, right? So it's exactly a condition logic. Everything between the equals and the question mark is treated like an if statement. All right? If it's true, so if stepping on landmine, then if it's true, it's going to evaluate the first part, the first thing after the question mark. So we could do health equals 50. All right? Then you put a colon, and you put what happens if it's false. So in this case, we could put 100. All right. So how this reads is, if stepping on landmine is true, this is the value. If else, this is the value. So if value else this. You can get really complicated with these two. If I want, I could put another one in here like big landmine, then health will equal 20, else the health equals 50. And this will still be valid, okay? All of this, if stepping on landmine was true, then this is going to evaluate. But this in and of itself is another ternary expression, which can then evaluate to either this, else this. You can get really freaking complicated with these if you want. This is just a shortcut. It's a cleaner way than writing a bunch of if statements just to set variables. Now, if you're just checking an if statement to then produce logic, obviously an if block would probably still be cleaner. But if you're just using if you're just checking conditional logic, conditional statements to assign value to, initializing a variable for the first time, it might make more sense to do it this way. All right. That is conditional statements. Super, super easy. The next thing we want to talk about is functions. Sorry. You've actually already seen functions. This mounted call that we're in is already a function. All right. The best way I can describe functions is functions are used to execute blocks of code. That's it. So, as we know, if we want to define a function for our page or our view instance component, whatever we're on, we can put it in the methods section. So within the methods section, which is, as we know, actually just an object, so the view instance itself is just an object with these properties attached to it. Methods is another object that's going to hold functions. You also can do that. So if I were to put, constant my first, let's say my new pet, as we discussed it before, right? My new pet equals, and I have health equals 100, and I have stomach contents equals this. Okay, you could create a function here, and you can call it eat, and you could do function. You want to bring in the food to the function, and then you would do this dot stomach contents dot push, and you would do food. Okay, push is a method of array. I haven't gone really over that with you. Just so you know, you can go to W3 Schools. Arrays and strings have methods. Any string variable and any array variable have methods that are utility for them, like string.slice, string.substring. It's a way to kind of slice a string up, get a part of a string. Arrays have things like push, which adds something into the array, pop, which takes something off of the array, join, which collapses the array into a string. They're just utility methods for working with that type of data, whether it be like a string or an array. We can go over those as they come up. I don't feel it's necessary to necessarily know or remember them. It's important to know they exist because you may be like, oh, I have a string and I need to slice out a part of it. I could do this the hard way and just manually go over every single character, or maybe I can check the string methods and see if they have a utility class that can do that. More than likely, there's a utility class for it. I have an array. Should I create a new array with the added object in it? No, you should take your existing array. There's a utility method to push an object into it. There's utility method to pull objects out of it. There's utility methods to sort your arrays, because remember, they're just lists, so you need to interact with these lists. There's utility methods to do that. In this case, all we're doing is we're creating a function. Within this function, we have code that is going to push whatever we pass into this function. So this right here is how you bring data into the function. This data, as it exists, as we're talking about it now, doesn't really have any value, but we're just saying that this is a variable that we're calling food, and whatever data is passed to this variable, we're going to push that into our array. How we would go about using this is we would do something like this. We would do my new pet dot eat, because we're calling that function. That function is expecting, see here, it's expecting a food variable, so we need to pass some kind of data to it, some kind of variable that is going to be food. So you could do that by, we'll create an apple, okay? And I'm going to create it like this. I'm going to create it as an object because I want to give it some properties like a name, health value, 10. Let's actually make that a number. That'll be cleaner. Hunger value, 5. All right. Now, if I want my new pet to eat that apple, I can pass this apple object into my eat function. It will add this apple object into my stomach contents array. For all intents and purposes, this line basically puts my apple inside of this array. So it would make it look basically like this. So I now have an apple with some data properties inside the stomach of my new pet. All right. That is a function. A function is just intended to basically group a block of code that you want to execute at will. You create a block of code that you want to be able to call when you want to call it, and you want to be able to pass it some data to do something with. That is a function. That's it. And you don't have to put it inside an object. You could also just do like function new. You can give it a name like this. Let's just call it eat to keep it simple, and we'll make it the same. All right. And then this time, because the function is not inside my pet, we're going to actually have to reference the pet this time. So we would do my new pet, then we would have to reference its stomach contents, and then we would have to push the food in it. This is a bad approach. This is considered an object-oriented approach. The reason why this is better and cleaner is because all of the functionality and the concerns for this pet is within the pet. You can still, from outside the pet, interact with it. You know, you can, in this case, you'd probably call this feed instead, right? So you could still feed the pet from the outside. But all of the logic and code, the access to the pet's own stomach, is done from within the pet's own object. Versus here, you are directly accessing the pet's stomach from the outside. It's the difference between like feeding your pet an apple versus slicing your pet open, putting an apple inside of its stomach, sewing it up, and then waking it up. You know, assuming the pet healed instantly or something like that. That's the difference. This is a cleaner approach. It's considered object-oriented. It's all contained within the pet. The pet's code handles itself. If you ever need to debug the pet or figure out what's going wrong with the pet, you look at the code only inside the pet. If we are modifying the pet from the outside, if your pet starts to become ill and you need to know why, it's going to be very difficult if there are lots of things in the world modifying the contents of your pet's stomach outside of your control, right? Versus if everything that goes inside of your pet's stomach comes from here, you could add some tracker code. You could be like, track feed, okay? And this code will execute every time your pet is fed, and you could store in a database who fed your pet, what it was fed. You have full control. It's all isolated to within the pet itself. You have control and access. It's siloed into this object. It's object-oriented. Versus if everyone and their mother is willy-nilly modifying the content of your stomach's pet with their own code, with their own block of code, you know, they're hacking into your pet's stomach and they're executing their own code. You have no control. You have no source of control, no siloed activity. That's bad. It's a bad practice. It works, but it's a bad practice, okay? But at any rate, a function is just a block of code. If you're defining it as part of an object, you know, it's a variable and you assign it. You can also do it this way. You can also do it constant my function equals, and then you could do, you know, the same thing that we did here. And in which case you would then call it my function and you would pass in the apple. All right, same thing. It's just a variable. You're assigning the function to the variable. Function, for all intents and purposes, could just be another data type for your variables. There's also the ES6 way, which is kind of the cleaner way to do it, which would be like constant my function equals da. This is called an arrow function. This is kind of the new standard. You don't really write the function keyword anymore. It's barking because I use the same name, so we'll say my function too. And it's the same thing. It's going to execute the same way. So you'll see it written a little bit differently, but for all intents and purposes, it's just a function, and a function just executes some code. All right, so that's functions. Now the last thing that we're going to need to go over are loops. So there are many occasions where you're going to need to loop over things. Like let's say that we have the, let's put this back. Let's say we have the stomach contents of my pet. Well, let's say that I now want to essentially digest the stomach contents for my pet. All right, I need to convert the contents into health and hunger. So we'll put hunger at 50. All right. Now, as you recall, on the last example, we would have added something like this. All right. And that's an object sitting inside of our array of our stomach. So it's an apple object sitting in our stomach contents array. All right. This function here can be used from the outside to feed our pet to get food into its stomach. All right. Well, now this food in the stomach, it kind of needs to do something, right? So I'm not going to go over strategies on how you would call the digest. We can actually, I guess I will. I'll just show you. We could set that up to a timer. So you could do something like set timeout, and then you would do my new pet dot digest. All right, and then you would do you would just call it, and then you would set the milliseconds. So we'll set it to 2000 milliseconds, which is just 2 seconds in time. So every 2 seconds, this function is going to get called. All right, now this function is intended to digest, the contents of the stomach. We need to get the objects in there, and we need to go over them and do something with them. This is where looping is going to come into play. There's a couple of different ways you can approach loops. There is the traditional for loop, which is going to look like this, and you would set it up let I equals 0. All right, then you do I is less than 5. All right, like this, and then you would do I plus plus. All right, now I haven't shown you the plus plus shortcut yet. Remember earlier when we talked about variable, let's say we create a new number, it equals 1. Remember I told you if you want to increase the number, you could do number plus equals 1, and our number now effectively, if we were to alert it, this would equal 2, right? Because we added a value to it. If we wanted to do it like this, it would now equal 6, right? Well, if you just want to increment something or de-increment something by 1, you can actually just do what's called number plus plus, number minus minus, minus minus number, or plus plus number. And when I say number, I just mean your variable. Your variable does have to be a number, though. If you try to call this on a string or an array or anything like that, you're going to get an error. It does actually have to be a number. This, as it sits currently, will work. This will also work because it's JavaScript, but this will create an error. All right. This only works because JavaScript tries to be smart. It's saying, hey, he's calling a plus plus on a string. If we were to convert this string into a number, is it a valid number? If so, let's just go ahead and do it, because we assume that's probably what he means. That's just a JavaScript thing. Every other language other than JavaScript would throw an error. JavaScript just tries to help you out a little bit. But at any rate, this basically is then going to result in 2. It's just going to increment it once. Now, you could also do it like this. If I were to do this, this is going to first alert number. So this is actually going to print 1, assuming I take this off. This is actually going to print 1, but then if I were to go like this and print number again, it's going to equal 2. I know that's going to sound confusing because you're going to ask, well, we didn't change it between this line and this line, right? Well, the side of the variable that you put the plus plus or the minus minus on, it has some small functionality attached to it. Basically, what this is saying is it's basically saying it's going to print out, it's going to provide the value of the variable first. So if you're passing this into a function, it's going to provide this, and then it's going to subtract it. Actually, let's make sure, because I'm a little bit curious now. Yeah. So it shows 1, and then it shows 0. If you pass this into a function, yeah, it probably works the same way. Anyway, so because it's on this end of it, it's going to alert number, which at this time is 1. And then after it provides the value, essentially after the alert fires, then it's going to subtract a value for it, which is why if we check the value again after this operation completes, we'll see the value is actually set to 0 now because it's minusing, right? Same thing for plussing. If we do it here, it's going to spit out 1, but then if we check again, it's going to be 2. Well, you can also do this. You can also put it on this side of it, and in which case now it's going to spit out 2, and then if we check it again, it's still going to be 2. Because the pluses or minuses are in front, and plus, 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 this is not a thing. There's only one shortcut, which is plus, plus, or minus, minus, and it will only increment up or down by one value point, okay? One full number. If it's 1.1, we're going to get exactly 0.2. You know, this will equal 0.2 now. All right. So it will only put it up or down by a value of 1 exactly. So when you're writing a for loop, this is how this works. Basically, I is going to start at 0. You have a condition statement here. So you're initializing a variable here. You have a condition statement, you're checking on this variable, you're saying if I is less than 5, then run the loop, and when you're done running the loop, increment I. So I equals 0. Is I less than 5? Yes, run the loop. So we would say alert I is, alright, I. Alright, now here's another thing that I didn't go over that could be a little bit confusing. This is called a string connotation. If you want to add a variable to a string, this is one way to do it, okay? Obviously, I is a number, so if I were to do this, it's just going to take the value of 1 and do actual math and add it to the value of I. I'm going to get 1 on the first iteration because 0 plus 1 is 1. On the second iteration, I'll get 2, obviously, because 1 plus 1 is 2, and so on and so forth. However, if you conjugate a string to it, so I is, instead of adding it like math, it's going to append it. It's just going to attach this as a string value to the end of this string. This is one way to write it. This is kind of the older way to write it. A cleaner way now would be to use this character here. These are the key next to next to your 1 key on your keyboard, and then you would put your string. So for all intents and purposes, it's just like the quotes or the single quotes. It does get treated as a string, but you can do a little extra trick in this that you cannot do in the other one. So like this, I could put I is colon space, and then you put a $sign brackets. See how it turned white now? And then everything inside these brackets is like standard JavaScript. It's not string anymore. See how if I put a space, it goes away? This is all a string again. It has to be specifically this set of characters, and everything in this brackets is now a JavaScript. I can put conditional statements in here if I want. I can execute a function in here if I want and have the function return a value. It's entirely up to me. But this is a cleaner way of writing, essentially. And you'll see if I do this, if I take away these braces, if I try to do the same trick within quotes, it doesn't work, okay? So that, the above line, is the same as this line. This is the new standard. This is cleaner, but this works just as well. And you could also do, hooray, you know what I mean? You can keep adding on to it, but it's easier to just do this. That's why this is cleaner, because concatenating one string, this doesn't look too bad. But as you start concatenating whole sentences and you need to plug things into, let's say you have a whole paragraph of text and you need to plug like 10 things into this paragraph, this is going to start to look a lot cleaner than this, but they do the exact same thing. They're just adding your JavaScript, either your variables or the result of a function or whatever, into this string. Okay. So anyway, if I were to let this run, you're going to see on the page I is 0, 1, 2, 3, 4. All right. So this ran 5 times. So this is a way to loop over and run something 5 times. If you need to run something an exact amount of times, and that amount of times is not based off of something, like a variable, like it is just an arbitrary, I want this to run 10 times. This is how you do it. You would use this kind of for loop, and you would do it an exact amount of times. Now, in this case, because we're digesting the stomach contents, I'm actually going to do it a little bit differently. There is an array method, a utility method for arrays, which is called for each, and this is how you would essentially do it. So basically, because it's got to be this dot, right? Oops. It's got to be this dots because it's my pet. All right, so since stomach contents is an array, you can do your array dot for each. And basically what this is saying is for each item in the array, it's going to fire this function. All right. I personally don't like this. There are certain situations when you're working with async and await code, which is asynchronous code, which is a very advanced concept. We'll get to that later. But when you're working with that kind of code, this type of loop can cause conflicts or errors. So personally, I don't use it. I just feel more comfortable doing it this way. I do a traditional for loop, very similar to the one I just showed you. Structurally, it's set up the same. It's not a utility method. It is the actual for loop. But instead of in here having that I logic that, counts the exact amount of times, we actually do let food item. So I'm assigning a new variable, and I'm saying of, and then I would say this dot stomach contents. So I'm basically saying for let food item of this dot stomach contents. So this for loop is going to loop over stomach contents and assign it to the variable food item. So now if I were to go alert food item, you'll see that it's going to loop over and it's going to alert my food items. It's saying object because it is an object. If I were to say food item dot name, for example, and let's put a second food item in my stomach so you can see. This one is an orange. All right. It's going to loop over. Apple, orange. It's looping over the items in the stomach contents. In this case, they're objects. So I can access the name property of those objects like this. All right. So then from here, it would just be a matter of basic logic. So I could go this dot health plus equals food item. Plus equals. I said it right, but I didn't type it right. Food item dot health value. All right. And then I can do the same thing for hunger. I could do hunger plus equals hunger value. And you don't have to worry about putting like minus because of basic math logic. If you want something to be detrimental to hunger or health, like let's say we have alcohol, which is common in survival games, it'll oftentimes give you health but lower something like mana. So in this case, we'll let it give us 10 health, but it's going to give us -5 in hunger instead, because it's going to make us more hungry, but it'll give us 15 health, whatever. You would do it like this, and this would still work out exactly the same. So if you add a negative value onto your hunger is going to go down, not up, right? So this right here, this little bit of code, will now process all of the items in our stomach and apply it to our health and hunger appropriately. So if we were to run it, so my new pet digests every 200 seconds, and then let's at the start of it, let's do alert, and we'll do pet health is, and then we will put our this dot health, okay, and then we will do pet hunger is, all right, we will do our this dot hunger. All right, so every time right before we digest, let's get that spitting out. And then as we digest, let's also alert what we are digesting. We are going to digest food item dot name. So then we know what we're digesting, okay? This is looking a little bit sloppier. Instead of using alerts, I'm gonna be a little bit sneaky here. I'm going to create a. This is called the data property on our view instance. Basically, it's just static data that we want. It's just a function, and all it should do is return an object. I haven't talked about this return keyword yet. I'll get to that in a second. It was part of functions. I should have went over it. I apologize. But if you just copy exactly the structures I have it, you can set data that can be accessible here. So instead of alerting this, because alerts freeze the page and it's kind of sloppy. Oh, come on, page. There we go. All right. We'll set up something called pet status, which will just be this. And we'll set this up as a pet. So our pet. And we're going to set this up as the pet object like so. All right. So all I did here was I created this data property so we can have data on our instance here. I'm creating a status for the pet, which is just going to be text. We can even say output text to make it more clear. All right, it's clear. And then we're going to have our pet. All right, now our pet should still modify itself just fine if I'm not mistaken. Okay. So now we don't need to now we could do this. So now we could do yeah, there we go. We'll just do it like this, okay? So now here we can put come on. In the HTML itself, we would have access to any of this data that we have on our data property. So up here, I could just put my pet's health is, and then in here, unlike in the these that I showed you where it's $ curly braces, in the HTML of the view template up here, you were going to use double curly braces like this, and then you would just access it. Our pet dot health is da. All right, and then I'm going to do the same thing. I'm going to create another one. I'm going to put da. All right, let's up this to 5 seconds. Let's up this to 10 seconds for now. Oh, all right, this has to go. Sorry, I'm getting an error here. And then because our pet is now on our view instance, if you are in a lifecycle hook or a method, although we don't have any at the moment, or a method of the view instance, and you need to access the view instance data or methods, you use the this. It's just like inside of our object, when you use this, it references the object itself. Well, because we're in a function that belongs to our view instance, if we need to access the data or the methods or anything, we use this. So we would do this dot our pet, right? Because it's defined within the data on our view instance. And now we would do digest. So this is how we would call it when it's attached to the view instance. So we're still going to do the same thing, which is on when this page mounts, we're going to want to set a timer. And this should actually be interval, not timeout. Timeout fires once, interval fires repeatedly. And I have it set to 10 seconds right now, just for the second. I'll put it back. All right. And let's give it a second. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Why did it jump up to 35 so quickly? It's like it fired. Oh, because I'm stupid. Okay. Putting these will cause a function to fire automatically the first time it's ran. That's not what I actually wanted. I wanted it like this. And because this is digesting automatically, let's add a button here that will add a food item. Okay, so we're going to do button, and we're going to do @click equals feed pet. All right. Feed the pet. Okay. Now we're going to need to put methods because we're referencing a method called feed pet on the instance. All right. Don't worry about what we're feeding it. We're just going to feed it an apple automatically. Let's empty its stomach contents because I think you get the idea there. Don't worry about these just because it doesn't have an example now. It's going to go like that, but it'll obviously get an example. So this dot our pet dot we're going to want to feed it because there's already a feed function, right? As part of our pet, we set that up already, and all it does is push the food item. And then what we're going to want to feed it is just this apple object. All right. So this will feed our pet. Every 3 seconds, our pet will digest all of the food in its stomach. All right. And that should be that. So let's take a look now. So if we head over, you'll see that our pet's health is 100. Its hunger is 50. Let's feed it an apple. The apple should now be in its stomach, and the next time the 3-second thing fires, nope, that didn't work. Okay, let me see if I can check why. Is it here? It's here. Yeah, here's our pet. Here's the stomach contents. It did not feed my pet. Interesting. Digest. Let's log the food item, make sure that it's firing. And we can check that by going into console. Cannot iterate property, simple, undefined. Undefined is not iterable. Alright, it is saying that, you know what, I don't think it's finding this. And it doesn't like that. So it would have to be this dot. Okay, I guess because I have it attached to the view instance now, this is overriding as to the view instance. So I'm going to have to put this dot our pet, which is going to access the view instance and then access our pet, and then it should be able to access its stomach contents. I know it's a little bit confusing. I apologize. It's just the view instance. There are better ways to go about set this up. I'm just trying to give you a general idea of functionality here. So I think this is what we want then. Nope. It still does not like this for some reason. Oh, right here, because this dot our pet. Sorry, yep, nope, still has to be like that. Okay. Alright. I think now we good. Reading stomach contents, yep. Okay, so this dot our pet stomach contents, this dot our pet health, this dot our pet hunger, this dot our pet. Yep, nope. It really does not like this at all. Okay. Okay, I'm just going to do this a little bit differently. I am going to make these actual functions then instead, and in which case we will just do it like this. This is not clean. This is not an object-oriented approach. I probably needed to make this a class, not just an object, to get the this references to work, but I do not want to jump into classes with you guys right now. So for all intents and purposes, we still have our rpet object. It still has its properties, but I'm moving the functions off of it for now just to keep things cleaner. Okay, So feed it. It's not going to need a food. We're just going to push the apple straight into its stomach. We're modifying it how we're not supposed to, how I said not to do it. Stomach contents. This should actually work now. Yeah, feed pet is not a thing anymore, obviously, because it's just feed. Yeah, okay, I'm not getting any errors. Okay, so our pet has its health, it has its hunger, right? I'm going to put an apple inside of its stomach. And then it should digest. Nope. Wow. Come on, man. Yeah, the apple's getting in there. The apple's in the stomach, so at the very least we can see every time we click the button, we are putting an apple inside of its stomach. So we know that's good to go. Something else is not firing. This, our pet. Oh, I'm stupid. The function's not located on our pet anymore, so there's no digest on our pet to fire. I apologize. That rework caused a lot of confusion. Okay, it's still the same thing. It's just I have to call it off the view instance, as I just mentioned. I had to put in methods and take it off of the pet object. It should have been a class. Classes are something we can discuss at a later point. But for all intents and purposes, this should still be fine. All right, so we take a look. Stomach contents of our pet are empty. And this is a plugin, by the way, called View Tools for Chrome. You should probably get this. It's helpful. Chrome View Tools. Just install this into Chrome, and it lets you see the data and functions and everything on your View instance during runtime. So the stomach contents are empty. Let's put a few in there, and boom, we saw it went up. Now it's going to actually keep going up because we're not clearing the stomach contents out when we're done. So we actually would need to do something like this. This.ourPet.stomach contents equals, and set it back to an empty array. So once we've digested everything, then we need to set it back to empty, so there's nothing left to digest. So let's refresh. Let's feed it an apple. It ate the apple. Boom. All right. Now we could sit here as long as we want. It's still firing behind the scenes. It's still digesting every 3 seconds, but the stomach contents are empty now, so there's nothing to digest. So let's put a whole bunch of apples in there. Boom. So you digested quite a bit. All right. 1 apple. Boom. Whole bunch of apples. Boom. All right. That's it. That's functions. That's, yeah. So the one thing that I did forget to mention on a function is you can return a value. If for whatever reason your function needs to return a value, like, let's say you have a function that is add 2 numbers, and it's n1 and n2, number 1, number 2, all right? You can return a value from this function, and you would just use a return key. And in this case, just return whatever value you want. So you could do something like constant value equals n1 plus n2. So value is going to be the addition of these 2 numbers, and then you could just return value. All right. You could also, and use return value. You could also just do it like this. You don't necessarily need to create another variable for it. You could just do it like this. Or you could do, like n1 type of n1 equals number. So we're checking the n1 is a number, and type of n2 equals number. So we're making sure that both of these are number. Then you return it just as we requested, the 2 numbers combined. Else you return a message that says please provide a number. All right. And regardless, this return is just going to return the results of this statement. So if both n1 and n2 were number types, it's going to return the value of the addition. Otherwise, it's going to return a string that says please provide a number. that's all the return keyword does. It's used for functions. A neat thing about loops, there are two different keywords you can use in loops, which is continue, I can spell, I swear, God, come on, and break, okay? Continue is going to tell the loop to stop for this particular run of the loop and immediately move to the next run. So let's say that I have code up here, the word continue, and then code down here. This code will never get executed. As soon as continue is executed, the loop is going to start over at the next run of the loop. So it's going to say, hey, we're done with this run of the loop, continue to the next loop run. Now, let's say that the loop is looking for something. Let's say that you're looking for something in an array, and you're looping over the array and checking each item to try to find it, but once you find it, you're done. You don't need to keep looking, you found it. So let's say there's 100 items in the array. If you find what you're looking for at item number 5, there's no reason to continue going through the array. You use what's called the break keyword. The break keyword tells the loop it's done. It's done looping. This loop will immediately stop right here, and then this code will start to execute. Okay? So that's a neat little thing about continue and break. Yeah, that's pretty much the basics. I mean, we're going to use those building blocks then. So remember again, it was... We'll get there. Oh, I can't go back that far. I'm going to try to remember off the top of my head. No, I mean, it should be easy, right? It was variables, right? Conditions, statements, functions, and loops. All right. Obviously, there's more to learn about each of these. There's some nuances about each of these. But what I've gone over with you today is the basic functionality. This is like 80% of what you will be doing with these things. And these things are like 99% of all the things you will be doing and using in your programming day-to-day logic. So you use these tools to create functionality, to build logic. You saw how we were just able to make a little pet program, and we were able to do things with our pet. You could see how we could easily now just start adding things on. Like we could add a little picture, and we can put in the function when it digests a little digestion noise or a little digestion animation picture that triggers, and so on and so forth. But we use these simple blocks and tools to build our functionality, to build our logic. These are the core fundamentals of all of programming, and these are in every programming language, every programming environment. You're going to find these. They may be called something different, they may be used a little bit differently, they may work a little bit of a different way, but if you are comfortable using each of these to create logic, then you can pretty much program in any programming language you want. You just have to kind of jump in and learn their syntax. You just have to spend a little bit of time like, okay, how does Python do variables? How does Java do variables? How does JavaScript do variables? How does Python handle condition statements? How does Python handle functions? How does Python handle loops? How does JavaScript do it? That's what you have to learn. But once you know how to use a loop, how to use a function, how to use condition statements, how to use variables, once you get good at using these to create larger, complex bits of functionality, and you are proficient at that, you are now a software engineer. You will now be good regardless of what technology or environment or language you are in. Yeah, that's it. So we use HTML and CSS to kind of build the look and feel of our application, and we use JavaScript to make it work, to make it do things. That's that. So I think in the next one, if you guys are interested, we could take this little pet example here, and we could build ourselves like a little virtual pet, a little Tamagotchi. I'll show you how to bring in some images, do some little animations, and we could build a little pet game with it.